Okay, so welcome to the last day of the machine learning 5 days workshop. And up to now, you all know that we have covered great content up to now, right? So with good practical examples, right, as well. And so today, the last topic under unsupervised learning we are going to discuss. And I hope you got something from the workshop, and let's discuss about the things in detail. But I think you got the maximum out of it. And the plus point with this online learning, right? So I actually, I'm not. Sometimes I'm not satisfied with online since the main reason that we can't get the feedback from you. I mean, feedback in the sense like the facial expressions, the body language, right? We can't read those things, right? Other than that, yeah, it's quite okay now. When I get the facial expressions, what I can see is whether you are whether you have understand whether you have understood it or not, right? So in that case, I can explain the same thing again and again, right, guys? So that kind of issue is there. So that's why I'm always asking you to ask me questions in order to get rid of that kind of disadvantage, right? But other than that, I think online education is quite good since the the plus point I'm seeing is that you can stay at your home, right? And you can comfortably participate to these lectures, right? And the other thing is that you can watch the recorded session and it will be available for your lifetime. Whenever you want, you can get the recorded session and you can go through that and cover. But don't misuse it. Now, what I saw here was that we have 30 students enrolled up to now, right? Some of they told me like few of them are going to enroll yet as well, but 30 are enrolled up to now. So out of these 30, now we have around 16 here. So some of them, I mean, there can be genuine and valid reasons, but other than that, what they think was that they are going to watch the recorded video. Some of they might have genuine reasons, but they are going to watch the recorded video. But I strongly recommend, as I mentioned, always attend the live sessions since that's what we are going to learn more effectively, right? And yeah, so uh, yes, right. So that's I mean, pros and cons, all of them are there, right? But personally, I like the comfortability that it's going to give us, and also the material access facility. Like we can have the recorded video and we can watch it any way we want comfortably. Sit, have your meals. Now even you can have your meals while attending the lectures, right? So have a snack, right? So very comfortable. And yeah, so I'm always trying to make with these facilities, right? So I'm trying to make it attractive, right? The background, the video, the audio, everything, right? So I always try to give the maximum to you. Okay, so I think, as I mentioned, you got the maximum out of the workshops. Yeah, so we have some questions. Do we have any recommendations for online machine learning courses? Yes, for further reference, yeah, I will provide you a few online courses as well as some references. I have provided these references in my course content as well. Yes, I will provide you some recommended online machine learning courses. But what I actually think is that we never get everything at one place, right? So that's one thing important. That don't think, okay, find a optimal tutorial that which covers everything. No, right? So actually, if you are trying to learn something yourself, it's quite hard since everything that you are going to expect will not be there at the same place. For example, now you can read a very good book written by a set of set of professors or doctors in MIT University or in Stanford University. You can get a course.
Huh?
Yes.
Hmm.
Yeah. Yes, Sandra. It was a mistake, right? Okay. Yeah. Anyway, now what I was talking about is that okay, so you can get a book or you can get a series of lectures which covers the theory, right? Theory well. But the other hand, yes, you have to have the theory knowledge well, right? So you need to have the tiny little knowledge on theory and everything. හැම තියරියක්ම හොඳට දැනගන්න ඕනේ. මොකද එතකොට තමයි ඔයාට හොඳට මේක කස්ටමයිස් කරන්න හැකියාව වෙන්නේ. But with that thing, you have to have the practical knowledge as well. So that's the most important thing. The other most important thing, right? You have to have the practical knowledge, like the Python implementation. So what I always suggest you is like it's quite hard to get these two things at the same place, right? Like I mean, the theory and the coding, right? Everything. So it takes some time, right? So don't think that you are going to learn everything. Now, the tutorials, let's say in YouTube or in somewhere, right? So there might be like implementations in Python or R or any other language, in JavaScript or any other language. There might be implementations in Python, right? The practical coding. But if you are always going to focus on them, you are going to miss the in-deep theory, right? So most of the tutorials that I have seen, they cover, I mean, the YouTube, they cover like the theory, only the only the simple things and not going to go into the deep, right? Only the simple things, and then straight away they go to the coding, right? But if you can watch some video like done by a professor in MIT University or Stanford University, right? So that professor or that lecturer is going to cover the theory in deep, right? Very deep, right? All the things you need. But he's not going to provide you the coding part. I mean the practical implementation part. දැන් මෙතන දෙකක් තියෙනවා. ඔයා කෝඩින් කරන එක බැලුවොත් එහෙම කෝඩින් කරන අය ගොඩක් වෙලාවට තියරි පාර්ට් එක කතා කරන්නේ නැහැ, right? ඒ වගේම තියරි පාර්ට් එක කතා කරන ප්‍රොෆෙසර් කෙනෙක් ගත්තොත් MIT University Stanford ඔය වගේ world renowned institute එකකින් එයා practical implementation එක කතා කරන්නේ නැහැ. He's going to go into the deep on theories, right? So what you should do, right? So this is actually what I was doing in like few years back, right? So you have to combine these two together, right? So first learn a theory, right? First learn the theory, then you have to go through, you have to find somehow a practical implementation for that theory, right? So that's the method that's the method that you are going to like I mean, if you want to be a good developer in this kind of fields, that's the best way, right? The theory is very important since like machine learning, deep learning, AI, uh, based on very complex and very comprehensive, right? Uh, Theories, right? And algorithms, right? So if you can't learn theory and if you're going to just learn coding, no, that's not going to work, right? So the thing that I always suggest, yes, give a priority. Now it's very I know that it's very boring when you are going to like, let's say, watch a 1 hour 1 hour lecture. That's quite boring, but that's the only method. Otherwise you only have the implementation knowledge if you are going to just focus on Python implementation, so everything, right? So what I suggest is like, okay, if you want to learn something, let's say support vector machine, again, I mean, in detail, get the support vector machine theory well explained by a qualified, I mean, not qualified, but a lecturer or a professor, right? So then get the practical implementation of the SVM, right? Likewise, right? So that's the suggested method. And yeah, so as I mentioned in the first day, right? So this is a beginner's course. So I think that you have the overall knowledge on everything, right? Overall knowledge in supervised learning, unsupervised learning, clustering and classification, regression, everything. So you have the fundamental knowledge. So I'm not saying that this is the end. No, this is not the end. This is like the beginning, right? Beginning in the sense that right? So this is kind of ice breaking session. You have the fundamental knowledge with you, and you have the practical implementation knowledge with you. Now this is where you are going to start everything, right? So this is where you are going to start your own project, your final year project it can be, right? So a project in your working place, right? Or your university project, right? So this is where everything is going to start. මෙතනින් තමයි දැන් පටන් ගන්න ඕනේ. නැත්නම් මෙතන නෙමෙයි ඉවර වෙන්නේ. දැන් අද 5 days. So we are going to finish wind this up here. Machine learning, okay, done. We are experts in machine learning. No, you are just beginners in machine learning. You have the fundamental knowledge. You have the fundamental knowledge in everything, like supervised, unsupervised, right? So I have taken you, like I have opened the doors and I have taken you somewhat in this path, some uh, up to some extent in this path, right? So this is from here, it's your responsibility to go beyond here, right? So this is the start. That's the most important thing. Now don't think that okay, this is finished, okay, machine learning, we know everything. No, this is where you're going to start. You have a basic knowledge, you have the fundamentals with you, you have the theoretical and you have the uh, practical implementation knowledge, right? Now I have doing these courses like around 4 years up now, right? 4 years now. So what I have seen, right? Still, some student call me and they ask about like very advanced things. So I feel quite happy. But that's like, I mean, 10%, right? 10% from the students that I have teached, right? I mean, uh, students from the past past courses, like, so the students that I have taught uh, out of these 4 years, right? So 10% of them, like, they always send me messages, they call me, and they sometimes they ask about very advanced things that I have never taught them, right? So that means they are doing their part, right? They are doing their part, they are studying their alone, their own, right? So they have start to work on their own, right? So that's the most important thing, right? So regarding the thing now, I have few students that they are doing some freelancing of jobs, right? So if there is anyone capable of doing freelancing jobs in Fiverr, Upwork, I suggest Upwork than Fiverr, right? So Upwork, so you are going to get, sometimes if you are a not advanced, but experienced seller in Upwork, they are ready to pay you like $100 per hour. But in order to get that kind of a job, you need to like have 4 years experience minimum, right? Or you have to complete like 100 projects. That kind of requirements are there. But there are opportunities like පැයකට ඩොලර් 100ක් ගෙවන jobs තියෙනවා, right? Upwork and Fiverr, I suggest you to go Upwork, since it has specifically it has data science, machine learning, these deep learning related jobs, right? So that's a new trend, right? I mean, we have web developers, app developers without any, programming knowledge. Even we can using WordPress, you can build web apps, right? And we can do graphic designing as well, right? Graphic designing and lots of things are there. Opportunities, but there's a higher demand for these kind of fields, machine learning, neural networks, deep learning, since very few are doing them, right? Only very few are doing them. So there are lots of chances, since now this is a very rapidly growing field, machine learning, deep learning, right? So here there's always a chance for you, right? So there's a good demand, right? So stay with this, do your own work, try to implement your own applications, right? And there will be lots of chances in future, right? Employment opportunities, freelancing opportunities, everything will be there. So this is a very, this is a rapidly growing, exponentially growing field, right? Okay, so one important thing after this workshop, uh, we have another workshop coming, deep learning and neural networks. So a small notice about that workshop. So this will be started, as per the schedule now, this will be started on 12th of January, right? 12th of January. And this will be, up to now, I have designed this for 10 days, right? So this will be going through all the deep learning and neural network things like supervised deep learning, unsupervised deep learning, reinforcement learning, and uh, feed forward convolutional neural networks, LSTMs, recurrent neural networks, transformers, generative adversarial networks, autoencoders, everything. All the neural network things that you need will be covered in this workshop, and it will be started on 12th. And it will be up to now, as I design now, it will be like 10 days workshop similar to this, but 2 weeks, right? 5 days and another 5 days. So there will be like 2 days, I mean, Saturday and Sunday off. Then thereafter, the next 5 days will be taken, right? So that's how the 10 days will be covered. That means, sorry, 11th, right? 11th to 15, the first 5 days, and then the next 5 days, 18 to 22, right? So 10 days workshop where everything will be covered about neural networks. So this is the next step about deep learning. So if you have covered these things up, then it's your chance to go to the next thing, right? So that's a small notice about this. Though the course content and everything, the payment and everything, all the details I will publish, right? So if you are interested, you can join, right? If you are interested, if you found the machine learning workshop interesting, or that's something that you got something from it, yeah, you can think about this and you can participate to the deep learning and neural network workshop for right. Until now, what I have decided is I have to I'm going to start it on 11th of January, and like it will be 10 days, and Saturday and Sunday will be off, right? 10 days, 10 consecutive days without Saturday and Sunday, right? The same time schedule and everything, okay, right? So that's the next advanced workshop to be right, to be conducted. And you have good I mean good 2 weeks to go again through the machine learning content we have covered, right? Yes, so I will provide you all the details about that workshop, and you have like 2 weeks probably to cover everything that we cover in machine learning. So then you can ready to this workshop if you are interested. Okay, so then today what we are going to do is to discuss about two important topics: dimensional reduction algorithms, the next topic under uh, unsupervised learning, and thereafter we are going to move to a topic called feature engineering, right? So you know that clustering, we discussed about one topic under unsupervised learning yesterday. So that was about clustering. So today we are going to discuss about the next topic, dimensional reduction algorithm. So this is also under uh, unsupervised machine learning. So all right, so unsupervised. So last time we discussed about clustering, and clustering we discussed about k-means and mean shift and did a good example. And thereafter today we are going to discuss about dimensional reduction algorithm, dimensionality reduction algorithms, right? And dimension reduction algorithm, what we are going to discuss today is principal component analysis. So we call it principal, yeah, PCA, right? So this is the algorithm that we are going to discuss today. Okay, so as the name suggests, what it means by dimensional reduction, right? Dimensional reduction, as the name suggests, we are going to reduce the number of dimensions, or to be exact, the number of features in a given data set before applying into a machine learning algorithm, right? Right, understood? So this is kind of a pre-processing technique actually, right? But it comes under unsupervised machine learning. This is kind of a pre-processing step, since what we are going to do before applying a data set into a machine learning algorithm, we are going to reduce the number of dimensions or reduce the number of features it has, right? We have already used one of the dimension reduction algorithms. So if you can remember the face recognition thing that we did on the day 3, right? The day 3, sorry, not here, not also here, yeah, here, right? So you can remember that we use uh, the I thought that we had some. Here, right? So you can remember that we did this kind of example where the face recognition was done, and you can remember that what we did was we apply like 2,500 features, 50 by 50 image into a principal component analysis, and we had the pipeline. And in the pipeline, we had the principal component analysis first. Then it reduced the given data set into like 150 features, and thereafter only we applied the that data set into support vector machine. I hope that you can remember this, right? So that's what we did. Like we use the this thing to analyze, I mean, reduce the number of dimensions of this data set, right? So this is something important, and this is something very useful since uh, since most of the machine learning algorithms, right? Most of the machine learning algorithm, they fail when you are going to provide high dimensional data sets, right? High dimensional data set. Uh, for example, like when more features, like okay, 10,000, right? So it can be millions, can be thousands, right? When you are going to provide high dimensional data, that means data with I mean uh, very high number of features, right? The machine learning algorithms fails, right? So in order to like overcome that issue, we have this topic called dimension reduction. So once a data set is given, the dimension reduction algorithms can reduce the dimensions as we did in this one, right? So 2,500 features, we are going to reduce it to 200, I mean, to 1,500 feature, 500 feature into 150 features, right? So that's what you call dimension reductions algorithms, right? So in dimension reduction algorithms, we have two main types called linear algebra methods and manifold learning methods, right? So what we are going to discuss today is something under linear algebra method called principal component analysis, right? So this is like types of dimension reduction algorithms. So two main types are there, linear algebra methods and manifold learning methods, right? So principal component analysis only, actually it is algorithm categorized under linear algebra method, right? Okay, so now what we are, I mean, then we have a manifold learning methods like isomap embedding and everything, like spectral embedding. So we have lots of manifold learning algorithm, as well as we have lots of linear algebra methods as well. But as I mentioned, I'm not going to go through each and every one, right? So that's not the thing. Like we have to spend like 3 months for this if you're going to go through, but I'm going to go through only one, the principal component analysis, and then we get the idea about what happens in principal component analysis, and thereafter we will apply into a data set and see how the principal component analysis works, right? So you have to have the idea, okay, dimension reduction algorithm, two main types, linear algebra methods and manifold learning method. What we are going to discuss today is something under linear algebra, and principal component analysis is the most commonly used and kind of a very accurate method of dimension reduction algorithm. So that's why we are going to discuss about principal component analysis, right? Since principal component analysis is actually used everywhere, and that's quite straightforward, and also that's a quite accurate method of dimension reduction, right? Okay, so you know what I mean, whether it's principal component analysis or anything, it simply, what it does is it's going to reduce the dimensions, right? Reduce the dimension. So what I'm going to do, let's do an example first and see how the principal component analysis actually reduce the number of dimensions, right? අපි දන්නවා principal component analysis නෙමෙයි ඕනම dimension reduction algorithm එකකින් කරන්නේ dimensions ගාන අඩු කරන එක. data set එකේ තියෙන dimensions ගාන අඩු කරන එක. ඉතින් ඒ dimensions ගාන අඩු කරන්නේ කොහොමද කියලා අපි ඉස්සල්ලාම අඩු කරලා බලමු. මේ data set එකක් අරගෙන සාමාන්‍ය data set එකක් දාලා ඊට පස්සේ බලමු කොහොමද අත්තර මේක වැඩ කරන්නේ කියලා, right? Okay, so we have a data set called x versus y in the materials that I provided you today, right? The materials that I have provided you today. So you have simply yeah, in the day file you have this x versus y, right? X versus y, and this simply contains some of the some values, 10 few, like this can be considered as a set of x and y, right? Please consider this as set of x and y values, that's all, right? No need to worry about the features and everything, right? So don't worry about what are these, okay, whether this temperature, humidity, right? Or no, don't worry about that. Just think that these are okay, set of x and y values, right? Set of x and y values. So let me assume, right? Let me assume that this is a data set with two features, right? So let me assume that this is like a data set with two features, right? This is the feature number one, right? And this is the feature number two. Now, no labels are available here, right? No labels are available here, just like feature number one and feature number two. Don't worry about the labels, that I'm going to assume that no labels are available, right? Understood? Right. So feature one and feature two. Don't worry about labels, assume that no labels are available. So let me take those x and y, right? I mean the feature one and feature two. Right? So feature one and feature two. So you can see this is the distribution of the data, right? This is the distribution data. Now we're not going to do anything related to linear regression, no nothing, right? So I just plot it, and it has some kind of distribution like this, right? So if you now clearly, I mean carefully look at this given plot, right? If you carefully inspect this given plot, right? Actually, what you can see, right? So we are going to now define something called the variance, right? Something called the variance. So you can see the variance of this side, I mean this side, right? Variance, right? So what I simply refers by the variance is kind of the like the distribution, right? The like simply say, we can say the minimum minus the maximum, like the variance, right? And if you like inspect the variance in this side, right? So you can see the variance, right? It's obvious the feature one has a higher variance, right? ලොකු වෙනසක් කියන්නේ ලොකු කොහොමද ඒ කියන්නේ a variance. What the mean word for the variance? Yeah, please someone suggest me a word. Range. Yeah, exactly, a good one. Range, right? So it has a higher range, right? So we say it's a variance kind of a thing. Now the thing is, I'm not going to go into the real math and go to the linear algebra, and there are lots of things: linear algebra, eigenvectors, eigenvalues, right? So lots of theories are inside this principal component analysis, right? Eigenvectors, eigenvalues, linear algebra, lots of things to be covered, but I'm not going to go into that level, but I will explain what happens actually, right? So what we did in k-means, mean shift, support vector machine, and everything, right? So you can see the variance is quite high compared with the variance of the feature 2. I'm talking about the feature 1. The variance in the feature 1 is quite high when we compare it with the feature 2, right? So for example, this range from 0 to 50, this range from 0 to 5, right? Understood. So that's kind of something that you can call as a variance, right? So now what we are going to do, okay, now you can see this is the feature 1 has a high variance, right? High variance, right? Then right, then what I'm going to do, okay, I'm simply going to take the principal component analysis without knowing actually what happens, but I'm going to take the principal component analysis like from scalar and decomposition and import PCA. Then I'm going to initialize the principal component analysis algorithm PCA n components 1. So this is simply saying, okay, I want to reduce the given data set to this PCA model. I want to reduce that dimensions up to 1. Here I'm again here, right? So we are going to create a PCA model, and what we say like n components equal 1s, that we are actually asking the algorithm, whatever the data set we are going to provide, reduce the dimension up to 1. තියෙන dimensions ගාන එකට අඩු කරන්න කියලායි මේ කියන්නේ, right? තියෙන dimensions ගාන එකට අඩු කරන්න කියලායි කියන්නේ, right? Okay, so then what we can do actually, yeah, so dataset.new fit transform, right? Actually the thing is now this fit transform, you can do it as in 2 steps as well, like the first fit and then the transform, right? First you can fit it and you can then transform it, or else you can do this fit and transform at once, right? Okay, so let me do the fit and transform here once, and I will let you know how to like first fit and get then transform, right? Likewise. Okay, so what happens here now, yeah, so let's do this like this, then it's better. Okay, so I'm going to fit the data set, right? Fit the data set into this principal component, only fit, right? Let's see, right? And then I'm going to print something from that model called components, right? Okay, so you are going to get something like this, right? So you are going to get something like this. Okay. Yeah, so you are going to get something like this. Now the thing here is that we passed 1, but the principal components that you have received here, like you have received 2 principal components, right? Now sorry, not principal components, right? So now this is a parameter that actually gives an idea about this variance. See, right? So it says like, okay, 99% of the data, right? The feature 1 has a variance of 99%. That means, okay, so if you compare the feature 1 and feature 2, right? So 99% the variance is with feature 1. Now don't think, okay, don't try to do the math here, right? mathematically calculate කරලා කොහොමද 99 එන්නේ කියලා හිතන්න යන්න එපා, right? There is some method of doing that using linear algebra and eigenvectors and eigenvalues, as I mentioned, but here it gives some idea about the variance, right? That means that, okay, so it gives, okay, so 99% of this data set is represented by the feature one, since it has the highest variance. I mean, the variance compared with the feature two, right? And feature two, it has a very less variance, a very less effect towards the data set. That's what it simply says here, right? Now, what you can see if, I mean, if you apply some other data set, right? If you apply some other data set, then it might be changed, right? For example, let me quickly get the iris data set, right? Iris data set, so the Excel file is available here as well, right? Now, yeah, so let me do the same thing and show you the principal components that you are, I mean, the components that you are going to get. Okay, so when you apply the iris data set here, how many components you should get? Yes, how many components you should get? Any idea? Not exactly. Yeah. Yeah. Others, any idea? Not 3. It is 4, right? So here now you can see we have like 2 features in this data set, right? So 2 features here, you can see. So it gives like the variance kind of a thing of 2 features. But here we have how many? We have 4 features. Setosa, sorry, sepal length, sepal width, petal length, and petal width. So 4 features. So it's going to give us the variance of the 4 features, right? Here. Sorry. Now, the thing is that we take the label as well. We take the label as well. No need to get the label on the feature, right? Virgin the versicolor the only the 4 features we need, the data. Right? So can you see the effect or the influence where if we take the whole data set? So it's kind of like this, right? So this has a 0.36. This has a minus. That means actually it's not required kind of a thing. The second one, I think the sepal width, it has a minus influence, kind of minus variance kind of a thing. So the most effective thing, most effective one is the petal width, right? And petal length and the petal, petal length. This is petal length, I think. And petal width and sepal length, so they are having quite similar effect, right? But the sepal width, unfortunately, it's having something like this, right? So it's actually giving you idea about the variance, how, what's the range of the distribution of each feature, right? So that actually explains you how important, right? How important this feature in the data set, how important this feature in the data set, how effective, right? Understood, right? So that's what it simply do, the principal component analysis. Principal component analysis එකෙන් කරන්නේ හැම feature එකම compare කරලා එයාගෙන් සම්පූර්ණ මේ data set එකට තියෙන importance එක, එහෙනම් අපි කියන variance එක in mathematical terms, right? So it's calculated here, right? So that's what you are going to calculate here. You get calculated here. right? Understood. Then what we can do once we fit it, now actually this is, I just wanted to show you, but now let me get it back here. Yeah, we have a question, let's see. When the variances differ, is it possible to normalize the data? Yeah, you can do normalizing and get it to a common kind of no. But if you yeah, you can apply some normalization in order to make the ranges equal. Yes, you can do it. Do that. Yes, that's something you have to do it with pre-processing. Yeah, that's not related to this, but you can normalize the data set and get it to a common range. You can do that. Yeah. Anyway, now this is what actually happens, right? This is what actually happens. Now, what we can do is we feed the data set into this one and we got some kind of idea about the importance, the essence, right? We can say that you can use the uh, essence of the original data, and then of what you can do, now you have an idea about this, then what you can do, then you can get the data set transformed to a, you can get the new data set, right? How you are going to do that is simply PCA dot transform. So you can now apply the data set and get the transformed one, right? Okay. So this is actually what you will get, right? This is what actually you are going to get when what? Huh? So this is simply principal component analysis converted your data set into one feature, right? Principal component analysis simply converted your data set into a one feature. So you had two features earlier, right? Now you converted it to a, like using the transform one, you can do that. But the thing is, now if you use the fit transform together, you can do it in one step, fit transform. But if you use fit separately and transform, you can do it like this. Anyway, you are going to get this kind of data set. So this is the new data set. That means this is what you are going to get when you transform the given data set into one feature, right? So this is how we are going to get it. දැන් මේක තමයි අර එක ෆීචර් එකකට ට්‍රාන්ස්ෆෝම් කරලා ගත්ත එක. දැන් මේක ඔයාලට කිසිම කොහොමද මේ මයිනස් වැලියු වෙන්නේ එහෙම කියලා ඔයාලට දැන් ලොකු ප්‍රශ්නයක් තියෙනවා නේද? හා? මම ඇත්තටම එක්ස්ප්ලেইন කරන්නම් කොහොමද මේක වෙන්නේ කියලා. right? right? මම කියන්නම් කොහොමද මේක වෙන්නේ කියලා. right? So the first thing that's going to happen is something like this, right? I mean, this is how actually it's calculated. Right? So this is how actually it's done. Right? So yeah, what we had was this one, right? Yeah, so let me quickly, let's take some time. I will do it manually, right? I'll do it manually and show you. Right? Actually, this is what happens. Right? So this one will be this array. That means this is the original array, right? So this will be multiplied with the transpose of this principal, I mean, transpose of the components. the transpose of the component. So this is what you call by the transpose of the components. Actually, I can't, yeah, I can't visualize it here, but anyway, this is how it happens, right? So it will be multiplied with the transpose of this matrix. Transpose, you know what transpose is, right? Right. This one, it will be multiplied with this one. So this is, I mean, from your O-level knowledge, yes. So this is something like how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it has 16 rows and 2 columns, right? So 16, 2. The size is 16, 2. And this has something around like 2, 1. So if you provide the dot product between these two, what is the result that you are going to get? I mean, the dimensions of the result, can someone predict or guess? Yes, so it's if you perform dot product between these two matrices, yes, what you are going to get, right? So you are going to get what? Yes, you are going to get 16 by 1, right? 16 by 1. So actually, do you know how this thing is calculated, right? So it's like this. First, this will be multiplied. Sorry, let me use another color, right? Another color like this. Okay. So this element will be multiplied with this, right? And this element will be multiplied with this, right? So then it's like this, 25.9 into 0.99, right? Plus 6 into 0.11. So these two will be added and the addition will be assigned here, right? Similarly, what happens again, this one will be multiplied with this and this one will be multiplied with this and added here, it will be added, right? So it's kind of like what? මොකක්ද වෙන්නේ ඇත්තටම? දැන් මේක අපි ඔය විදියට හිතන්න නැත්නම් මෙහෙම හිතුවොත් එහෙම ඔය මොකක්ද ඇත්තටම කරන්නේ? Right? So it's simply doing something like this, right? If you assume that this is something like a weight 1 and weight 2, right? It's like multiplying these two by a weight, right? And adding them together, right? Weights දෙකකින් වැඩි කරලා එකට එකතු කරනවා වගේ, right? එතන මොකද වෙන්නේ? අර weight එක වැඩි එක්කෙනාගේ වැඩි portion එකක් එනවා, right? So I mean, the feature which has the higher weight, right? So you are going to get a higher portion from that, right? And which has the less weight, we are going to get a small portion from that, and we are going to add them and assign it here. තේරෙනවද? මේක නිකන් හරියට weights දෙකකින් ගුණ කරලා අපි මෙතනට add කරගන්නවා වගේ. يعني අර දෙකක් තිබ්බ එක දැන් එක කරනවා. ඒක කොහොමද කරන්නේ? මේ වගේ weights දෙකෙන් ගුණ කරලා එකතු කරනවා. Right? So it's giving like a what? Weighted sum. It's kind of a weighted sum, right? Understood? Got the idea? Weighted sum එක වගේ. Right? It's like something like the weighted sum, right? So this is the answer that you are going to get here. Data set, principal components, transpose, and this is what you are going to get, right? But okay, is this equal to this one? No, right? දැන් මම මේ කියන්නේ කොහොමද මේ මෙයා මේ transform එක කරන්න කියලායි මම පෙන්වන්න යන්නේ. එතකොට ඒක කරන්නේ මෙන්න මේ original data set එක වැඩි කරනවා principal components වල transpose එකෙන්. එතකොට ඔයාලට මෙන්න මේ වගේ එකක් තමයි එන්නේ. But you can see it's not near even near to this one, right? Right. So what you have to do, one last thing you have to do, what's the last thing that you have to do is you have to get the mean of the data set, right? You have to get the mean of the data set. I mean this one, right? You have to get the mean of this one and deduct the mean from each and every element of this matrix. මේ matrix එකෙන් mean එක සම්පූර්ණයෙන්ම හැම element එකෙම mean එක අඩු කරනවා. එතකොට මේක තමයි වාට එන්නේ, right? So this is quite equal to this one, right? So right, so you can see, right? Understood. So then how actually it's done, right? How principal component analysis simply reduce the dimensions, right? It's going to identify the variance of the data set, the feature, individual feature of the data set, right? Then that thing will be multiplied with the original data set, and this is something like getting the weighted average over each and every feature, right? අර වැඩියෙන් ඕනේ මොකක්ද කියන්නේ දැන් බලන්න. එතකොට මෙයා multiply වෙද්දි මේ 0.99, right? ඒ කියන්නේ මෙයාගෙන් 0.99 ගන්නවා, මෙයාගෙන් 0.11 ගන්න, right? තේරෙනවද? එතකොට තමයි මේ කීයද හැදෙන්නේ? 25 ගානක් හැදෙන්නේ, right? Understood. මම පෙන්නන්නම් ඔයාලට ආපහු. අපි ඔරිජිනල් data set එක print කරමුකෝ. Right? So this is the original data set, and let me print the principal component as well, so then you will clearly understand what happens, right? See, දැන් මේක හැදෙන්නේ කොහොමද මේ? 25 is multiplied by 0.99, 6 is multiplied by 0.11, add them. This is what you are going to get, right? Then this one, 30 multiplied with 0.99, 6 multiplied with 0.11, and this is what you are going to get, the addition, right? So that means what, like by the variance, so it's kind of acting as a weight. These two are acting as a weight, right? And what we simply do, okay, we give the, I mean, the weight according to the variance. මෙයා තමයි වැදගත්ම එක්කෙනා කියලා කියන්නේ. data set එකේ කියන මෙයා තමයි වැදගත්. මොකද යාගේ variance එක වැඩි. That's so what happens. We are getting like when you are creating the new value, when you are going to convert it to a 1, we give 99% to this one and only 0.1% to this one. Right? මොකද යා තමයි ගොඩක්ම මේකේ principal, right? So it's the principal component. This is the most principal component of this one, right? This is kind of a least principal component, right? So it's kind of a like getting weighted sum, right? Weighted sum. Understood. Then actually, then we have to do some other thing. Now this is actually not required, but it's done usually. Then from each value, right? From each value here, from each value that we are going to get, the mean will be, right? So you know what, let's see what's the mean here. Right. So 27 is the mean. So from each value, mean will be subtracted. Right? So that's how we are going to get the principal, I mean, that's how we are going to reduce the dimensions in principal component analysis, right? So hope you understood, right? Any questions, right? So it's basically giving a weight to the feature and multiplying all the features by weight, that weight and adding them together, right? Understood? Got it? Right? I mean, This is how I just show you how it's done actually, right? Without any libraries. But this is simply you can do it using this PCA.transform, and what you have to provide here only the number of components that you require, right? So if you can remember what we did in our uh, the face recognition example here, we provided the number of components we need, and these things are like some additional parameters I will explain probably later, but the number of components we need, we provided it, right? That's what you need to do. No need to do it manually. මම හැමදාම මේ manually කරන හැටිත් පෙන්නනවා. ඒකයි මම මේක අදත් පෙන්නුවේ, but from the code you can get it done, right? Understood. Okay, now quickly I will show you a practical application. I mean, you can always use principal component analysis for this kind of a problems, right? What it means, like, okay, to get the, I mean, this face recognition one, we have 2,500 pieces. So before applying it to SVM, we can create a pipeline, right? We can create a pipeline. Okay, we have the principal component analysis, we have this SVC. So before applying to the support vector classifier, it transforms to the principal component analysis and it does something like this, right? So this is something, I mean, the general usage of principal component analysis. මේක තමයි සාමාන්‍ය principal component analysis මේ වගේ දේවල් තමයි use කරන්නේ. ඔය images එක්ක වැඩ කරද්දී machine learning algorithms එක ගොඩාක් use වෙනවා. අපිට මොකද ලොකු features ගානක් තියෙනවා නම් we are not going to apply it direct to the SVM, or when we have like large dimensions, large number of dimensions, we don't apply it to the support vector machine or the what you call the machine learning algorithm directly. We have to just pass it through a principal component analysis algorithm and get the dimensions reducted, and then only you are going to apply it to this kind of the SVM, right? So that's a quite straightforward application of principal component analysis, but here very interesting and a very simple application we can think of, right? So here now we have a data set, an inbuilt data set called digits, right? So we have some digits data set in our this is provided by scikit-learn, right? This is provided by scikit-learn, and it is an inbuilt data set. You can load inbuilt data set like this from sklearn data set, load digits, right? So this is actually what it has. Yeah, so I can get the images. I will show you. Images equals digits dot images, right? Yeah, let me show you what this images actually is. Now don't worry, this is the inbuilt data set. Make a scikit-learn වල ඇතුළේම එන data set එක, digits data set, right? Yeah, so you can see it has 1,797 8 by 8 images, right? So this is actually a data set available in scikit-learn as an inbuilt data set, right? So it has simply, this says what, when we print the images.shape, it says 1,797 888. So that means it's simply 1,097 images which has like 8 by 8. The size is 8 by 8, right? So if we simply plot one of them from matplotlib, import pyplot as plt. So plt.imshow, right? plt.imshow images 0, right? Okay. Yeah. So what you can do, let me use the color map to gray, otherwise it will be shown as this, right? Okay. So this is what you have in the data set, right? In the data set, that means this is one, the first. So we have 1,797 images, right? This is, I'm just printing the first one out, right? So if you print the 102, right? So it's something like this. It probably 5, right? I think, isn't it? 5 or 3, right? So this has simply 1797 images. Size is 8 by 8, so it's obvious, right? So you can see here, right? 8 by 8, 8 columns and 8 rows, right? So if we directly take it as a data set, the one image, how many features are there? Yes. If we take this as a data set, one image, how many features are there? Directly, if you take it directly. Yeah, 64, right? So exactly it's 64. Very good, right? Since we are going to assume like each and every pixel as a feature, right? Each and every pixel as a feature. So in that case, we have 8 by 8. So that means 64 features, right? Okay, now my point. You can plot these kind of things, right? So the train, I mean the temperature, humidity, you can plot, right? And this feature one, feature two, you can plot. The weight, height, you can plot, right? But can you plot the images data set and see the distribution? How those data points, how each digit is located, right? How can you draw the can you plot the iris flower data set in this kind of plot? Iris flower data set, like taking features into axis, right? By taking features into axis, right? And see the each flower, the distribution of each flower. No, you can't do that, right? Why? Iris flower example has 4 features, right? Sepal length, sepal width, petal length, and petal width. So you never going to plot it. Since you can't plot, what the maximum dimensions, what are the maximum dimensions that you can plot a graph, right? But you can't go beyond 3D, right? You can't go beyond 3D, right? So how you are going to draw the iris flower example and see the distribution of it? You can't do that, right? So if you can't do it for iris flower example, you can't do it for digits, right? So digit has 64 features. You can't do that, right? Understood? But we have a method of reducing the dimension. So what we can do is we can plot a nice plot like this for the digit, right? So what we have done here, right? So we got the data set, the digits, we have the digits. So digit simply is like 1797, 64. That means it has 64, the flattened version of the images. So this has the flattened version of the images. I mean the digits data, right? So what we are going to do is that we are going to pass it to the, or we'll do that like we'll do it like this, then otherwise you are confused what this simply says. Right? So I'm going to get the data like this. Right. So what I'm going to do, like I'm going to get the, so if I print it like this, so this is the flattened version of the, right, the flattened version of the images, right? So 8 by 8 image, each of the digits are flattened here, right? Each of the digits are flattened here. So we have 1797, 64. That means we have 1797 images, the flattened version of those images, right? It's simply like a data set with 64 features, right? It's simply like the data set of 64 features. So what we do, that we initialize the principal component analysis, right? Where we are going to take only 2 features. So this can be done like this as well, or else you can provide it like you can just provide it to, or I mean, then you can provide it right like this, or else you can just provide it like this as well. Right? Okay, so we initialize the principal component analysis of like which can convert the given data sets into 2 features, right? Right. So then what we'll do, we apply the data, this 179, 100, 1797, 64 features data set into this principal component fit transform. So we directly do the transformation and we get the new data, let's say like new data, right? Then we get the new data, right? And what you can do, the shape of the, what you can see, the shape of the new data is 2. That means 1797 by 2. That means the 64 features, right? We have converted it up to 2. Right? Okay, one last thing. If you can remember, okay, how many values this going to give us? No, we will do it later, right? Okay, yeah. So we have 2 features here. So we have 2 features. Right? Then we can plot the first feature versus the second feature. So we convert it to 2 features. අපි දැන් මේක features දෙකකට අඩු කළා, right? So if you want to see what this simply gives, it makes no sense, but you can see like 2 features. We don't know what the meaning of this, right? But it simply gives us like 1797 with 2 features, right? So then you plot the first, if you plot the first feature versus the second feature, right? This is what you are going to see. So we can't, right? So we can never think of, I mean, we can never think of a method of initializing the digits data set like 64 features, but we did it using the principal component list and we converted it to 2 features. But can you see, right? This is quite successful, right? Why? This is kind of a clustered thing, right? So see the digit 0, right? The digit 0 is here, right? And the right, the digit 2 is somewhere here, right? And digit 6 is somewhere here. Digit 4 is somewhere here, right? So you can see it's kind of a clustered, right? So that means simply even using 2 features, no need to have 24, I mean, no need to have 64 features. The digits can be represented using 2 features as well. That's what it simply says, right? Understood? Right? So I think if you remove this alpha parameter, probably we can see it clearly. I'm not sure, but let's see. Yeah, now it's not transparent, but yes, you can see somewhat, I mean, you can actually see a very good separation, segregation, right? See, what we did just, we had the data set of 64 features, like 8 by 8 image. So using the principal component analysis, what we did was we split it into, I mean, we reduced that number of features into 2 features using the principal component analysis. And this is what you are going to see, right? So you can see like it has a good separation, right? If you compare the digits, right? So it means, okay, what this means. So the 0 digit is given by this black color, right? And this kind of color, the digit number 1 is given. And from 2, I think somewhere here, right? So this is actually the digit 2. And digit 3, I think this is digit 3, right? And this is digit 4, as I can see, right? And this is 5, like this, right? So it's kind of a, right? It forms a visible clusters, right? So it forms some visible clusters here, right? Understood, right? So a very useful thing other than that, the other than dimension reduction for before applying into machine learning data sets, right? So as I mentioned, principal component analysis can be also always used for applications like what we did. Can you remember that the face recognition thing? So yeah, no any doubt, you can apply principal component analysis for those kind of applications. It's quite straightforward. But other than that, the principal component analysis can be applied for uh, visualization of features, right? So you can't see the distribution of digits since it has 64, but what we did was we reduce it up to 2 features, and then we got it. I mean, we can see the distribution, right? දැන් මේක හිතා ගන්න පුළුවන්. දැන් අර පික්සල්ස් 64කින් රිප්‍රසන්ට් කරන එක දැන් මොකක් හරි ෆීචර්ස් දෙකකින් රිප්‍රසන්ට් කරනවා, right? Earlier it was represented by 64 pixels, but now it represented by 2 features, right? Now the idea here that these 2 features are created, right, in terms of those 64 features. 64 features මොනවා හරි weights වලින් ගුණ කරලා තමයි මේ දෙක හැදිලා තියෙන්නේ, right? So these 2 features are created by I mean getting some weighted sum from that 64 features, right? Understood? Got it? So another application of principal component analysis, so you can use it for like feature visualization, where you have more than 3 features. When you have more than 3 features, you never be able to visualize it and see the distribution of the data, but using the principal component analysis you can easily do it, right? And the most important thing then I'm going to discuss, right? So here, can you remember I told you that I tested this and got this number of components like 150, right? I told you that I actually did some digging and got this 150. Otherwise, in the face recognition thing, right, the face recognition thing, we had 2500 features, so I directly reduce it to 150 features. So there was a question, why you select 150? Then ප්‍රශ්නයක් තිබ්බයි 2500 150කට මොයා reduce කරන්න, මොකද 150 කියන number එකයි. Why you are going to use all 150? Is there any special case? Yes, there is. So we have to, like, based on some theory and based on some constraints, when you are going to do this principal component analysis, right? Got it? මේ 150 ආවේ ඇයි කියලා, 150 කොහොමද decide කරන්නේ? අර face recognition වල මම 2500 150කටම අඩු කළේ, right? Likewise, how to decide the number of components that we can reduce a particular given particular data set into, right? So we are going to see how it's done, how we can decide the number of components that we are going to reduce a data set into, right? බලන්න යන්නේ කොහොමද data set එකක් දුන්නාම ඒකේ features ගාන අඩු කරන්න පුළුවන් number එක, minimum number එක, right? ගන්නේ කොහොමද කියලා අපි බලන්න යන්නේ, right? So you can visualize it using this method, right? So under the choosing the number of components, right? So when you have right, we can use this method, principal component. We are going to initialize a principal component analysis model, and then this is for the earlier one, the data set, the digit data set. So we have 64 features, right? And then we plot the explained variance, right? Explained variance, cumulative sum of the explained variance. Now I'll explain what this is about, right? So when you are going to run this, you are going to see this kind of a graph, right? So how to read this graph? So x-axis, you have the number of components, right? You have the number of components, right? And you have here the something called the cumulative explained variance, right? So this simply says right, like this. So when you have the here, carefully see, when you have the 64 features, see 64. When you have all the 64 features, it has a cumulative variance of 1, right? That means it has like all the data is perceived, right? Sorry, all the data is preserved, right? Monoth lost vela naha. Nothing is lost, right? We have a cumulative explained variance of 1, right? When you have 64 features. When you are going to reduce it like 50, right? So what happens? You have, okay, 95, 97, right? I think it's better if I can use direct lines here. Right? So when you have 64 features, you have the, it has 1. So when you are going to reduce it up to 50, right? So you have around like 97 something, right? When you are going to reduce it up to like number of features into 40, you have something around like 95, right? When you are going to reduce it up to 30, you have something like 90. Right? When you are going to reduce it up to 20 features, you have 85. When you are going to reduce it up to 80, sorry, 10, right? Understood. So it's like you can get the idea like, okay, how many, I mean, yes, yeah, how much information is lost, will be lost when you are going to reduce the number of features, right? Feature ගාන අඩු කර කර එද්දි කොච්චර information loss එකක්, කොච්චර accuracy එකේ, එහෙම නැත්නම් කොච්චර මේ data set එකේ essence වල කොච්චර අඩුවීමක් වෙනවද කියන එක තමයි මේකෙන් කියවෙන්නේ, right? So like it's always suggested to have like 80% minimum, right? 80% minimum. Not always, but it depends on the application. But generally, we can say like you should have a cumulative explained variance at least more than 80%, right? So that's how we are going to do it, how we are going to decide it, right? So shall we apply this thing into our that face recognition thing, right? And see how many, I mean, yeah. So data and target. Probably I have to get the principal component analysis. Yeah, so now what I'm going to do is I'm going to do this for the that, can you remember the face recognition thing? Probably I will show you the, yeah. So training the SVM, right? So this is from this, I mean, day 2 material, training the SVM, right? So you can remember what we did there, right? Finally, we saved the data set into data and target. So in this third code, we loaded it into like data and target. Now what I'm going to do, I'm going to apply that data into the principal component analysis and plot that graph that we just implemented. Right. See, so right, so I use 150 features. Can you remember 150 features? So it has around like 95, right? See, 95% cumulative explained variance. So it's quite okay to reduce it up to 150, right? It's quite okay to reduce it up to 150. Understood? Got it? Now, what I'm talking about now, in the example that we did for the face recognition, we reduce it up to like 2,500 features up to 150, right? So there in that day, the second day I'm talking about, second day I directly use it like 150, and I told you that in the last day I will explain why I do that, right? So here's the proof why I use 150. It simply gives you like 95% explain variance, right? So that means like 95% of information is preserved, right? No any loss done, right? So obviously, when you are going to reduce the dimensions, there will be information lost. That's something obvious, you can understand, right? Reducing the number of features, definitely it will cause information loss, right? It will cause information loss. Got it? Therefore, we have to always check this and see how many information is lost, and have to always keep a track on cumulative explained variance, and always try to keep it more than 90. 80 is good, but if you can keep it more than 8, if you can decide the number of components by keeping it more than 90, that would be quite good. Yeah, yeah, it's 2,500. Now, actually, if you are worrying about here why it's not 2,500, I think that's like it stretched the data set. I mean, the number of features. So actually, the upper target should be 2,500. But I think it's doing some assumption and not showing the, since actually like up to 2,500, it will be same kind of a thing. Like it will be like quite closer to 1. So it's taking from around 150, I mean 250. Right? Okay. So hope you understood, right? Got it? Got the idea? So you can always use principal component analysis before applying a data set into machine learning algorithm. So if it is too large in the sense it has like higher dimension, higher number of features, right? Then what you can do simply is that you can use the principal component analysis, since machine learning algorithms will fail, right? With higher dimensions of data sets, right? So you can, you can apply higher number of data sets, higher dimension data sets, and see the accuracy and everything. You can then get an idea about the performance, right? So if it is giving less performance with the raw data, raw data in the sense like the original features, then you can use principal component analysis or any dimension reduction algorithm and reduce the number of features into some number, right? And you can then you can create a pipeline, right? So you can create a pipeline and then you can apply that into your machine learning algorithm using the pipeline. But how to decide the number of components? You have to get this graph, the number of components with the cumulative explained variance, and you can decide the number of components that you are going to use simply by take a value which gives you more than 90%, greater than 0.9 explained variance, right? Understood? So from here it's safe, right? Understood? 0.8 is also fine, but you can do that, right? කොහොමද කරන්නේ machine learning algorithm එකකට දාන්නකොට data set එකක් ලොකු features ගානක් තියෙනවා නම් data set එකේ ඒක ඔයා දාලා බලන්න. දාලා බැලුවාම ඔයාලා පොඩි accuracy එකක් ඒ වගේම ඔයාලට එන measurements metrics වලින් ඔයා බැලුවාම ඔය මොනවද මම කතා කළා අර වීඩියෝ එකෙත් ඔය මොනවද F1 score Then F1 precision recall, those kind of measurements also you can take. And thereafter what you can do simply, if your algorithms gives you like a less performance, අඩු perform එකක් නම් දෙන්නේ matrix අඩුයි නම් accuracy අනම්ම නම් අඩුයි නම් ඊට පස්සේ ඔයාලට පොඩ්ඩක් පුළුවන් ඒ algorithm මේ data set එකේ features වැඩි නම් වැඩි කියලා හිතනවා නම් ඔයාලට 2500 3000 10000 වගේ තියෙනවා නම් try with principal component analysis. Principal component analysis දාලා බලන්න. principal component analysis දාද්දී ඔයා අඩු කරන features ගන්න decide කරන්න මේ graph එක ඉස්සලාම ඇඳලා ඉන්න ඕනේ. You have to plot this graph and see the number of components that the optimal number of features. So you can decide it by taking this graph and take a number which gives a cumulative experience variance than 0.9, right? Then it can be good. It will be it may give you good accuracy. So what you can do then, create a pipeline, right? Create a pipeline, and with your principal component analysis and the machine learning algorithm you are going to use, and do the training and get the predictions and get results. Understood, right? So that's how simply you are going to do that, right? So I think you got the idea, right? I think you got the idea. Right? Any questions? Any doubts you may have? Right? Any doubts you may have quickly? Seems no questions. Okay, great. Yeah. Now the next and the last topic for our workshop, feature engineering, right? Actually, as I mentioned, this is a topic comes before all the topics, right? Before going on to clustering, supervised, unsupervised, everything, we have discussed about feature engineering, right? Since this is something that we are going to do at the first place, right? So this is kind of a pre-processing technique, right? So this is something that we are going to do before applying a data set into a machine learning algorithm, right? So this actually focus on pre-processing data sets, right? Before applying into machine learning algorithms. But thing is, I shifted it to as the last part of the workshop. Since if I start like feature engineering section, as I mentioned earlier, I told this earlier as well. If I start feature engineering first and discuss about how we can deal with features and how we can impute missing values, likewise, if I explain everything, you are not going to understand, since you don't have anything. If you don't have the idea of machine learning algorithms and how they works and how we can train and everything, right? Therefore, what we did was we discussed about all algorithms we train, and we got results. We got 99% accuracy, we got 98% accuracy, and we got like 80%, 80 R2 score, right? And we implemented lots of applications. And thereafter, finally, we are going to discuss about feature engineering. So you have a good background knowledge about all the algorithms, so it will be quite easy. Now you know how to train machine learning algorithms and how to evaluate them, how to optimize them, everything you know. Now what you have to do, okay, before applying your data set into a machine learning algorithm, you can follow these things, right? Okay, so feature engineering is simply about dealing with features, right? So that means this is simply this, we are going to explain some techniques or some methods that we can use before applying the data set into a machine learning algorithm and train it or evaluate it or test it. Before applying the data set into a machine learning algorithm, you have to use sometimes, not all the times, but sometimes you have to use some feature engineering techniques. So this is simply something about data pre-processing, data sets pre-processing, right? So we are going to process our data set, we are going to do some modifications into our data set or our features, right? Our columns in our data set before applying them into machine learning algorithms. Sometimes machine learning algorithms may fail if you apply the dataset without following the feature engineering techniques or data pre-processing. තේරෙනවද? සමහරවිට machine learning algorithms accuracy හරියට දෙන්නේ නැහැ. සමහර results හරියට දෙන්නේ නැහැ. Feature engineering techniques ඔයා apply කරලා තිබ්බේ නැත්තම්. Right? Understood. So we have lots of feature engineering techniques, right? Imputation, categorical encoding, outlier handling, polynomial features, binding, scaling, log transform, feature selection, feature grouping, feature split. So I have lots of topics under feature engineering. So simply this is talking about data pre-processing techniques for data sets before applying them into machine learning, right? So we will talk about the most important and the most important topics out of these, right? Imputation, categorical encoding, handling outliers, scaling, right? And finally, we are going to talk about feature extraction, right? Feature extraction finally. I think it's finally feature extraction. So we have lots of things to be discussed here, right? Okay. So the first one is imputation. Right. So imputation simply, what do you mean by imputation? Your data set. Now, the data sets that we have used up to now, we didn't experience this kind of issue. But sometimes the general data sets, they might contain missing values, right? Empty values, right? Missing or empty values. Now, missing or empty values, this can be due to several reasons. Can you point out few? Can you point out few? Yes? Reasons for missing values? Yes, let's see some ideas from you. Not available, okay. Good, any others? Not available, yeah. Carelessness, yes, human errors, good. Human errors can be there. Carelessness, any other? One more, please. Wrong values may entered, yes. But wrong values, wrong value can be there, right? Wrong value can be there. I'm asking about like what is the reasons for missing values? If there's a wrong value, that's fine. A value, even a value is there, right? Okay, encoding errors, yes, exactly. So let's say some practical examples. Okay, so you are measuring currents and you are measuring voltages, right? And your sensor is there. One of the sensors is there. So battery powered device is there. A battery powered device is collecting voltages and currents of a specific device, right? Let's say a particular device. Suddenly a power cut. Since the device is working from a battery, let's say a mic controller, since it's working from a battery, the sensors like they work, but no current to be measured. So current and voltage value will be 0. It's missing, right? And when you are going to measure the sepal length, sepal with petal length, right? Accidentally, the sepal is not there. නේද? අර මලේ පෙති sepal length petal mine or petal එක නැත්තම් මොකද වෙන්නේ? Petal length with mind බෑ ඒක නෑ not available. Right? Sometimes human when they enter these values there might be like some missing values, right? So due to the human errors, right? Due to some human errors. So we can point out lots of possible reasons for missing values, but they can be there, right? They can be there. So what we have in our data set, so we have a data set here called penguin sizes. So this is a data set available. So since like, no use of having this data set, but I wanted to just get a sample data set. That's why I collected this one. So it simply says it gives you information about the penguin size CSV, right? So I think the target probably will be the gender. male or female, right? So species and island, Kalman length, Kalman depth, flipper length, body mass, probably in grams. Is it kilograms? Any grams, right? So, ah, very light, right? Penguins, right? Yeah, this is grams. So 30. I'm not sure, but anyway, don't worry about that, right? So anyway, the island is there, some kind of islands in like Atlantica or somewhere, I don't know, right? And yeah, the, and you have some right length, the depth, and the flipper length, the body mass, and the gender. So I think probably this would be the target, right? The target, the label, whether it's a female or a male, right? And these are features simply, right? So you can see like some numerical features are there here, right? Some numerical features are there, right? Some numerical features are there, and some categorical features are also there, right? Categorical features, the right. So the island, right, and this is also can be like, I mean, this is the label, but it also uh, can be taken as a category, male, female, a categorical problem, a classification problem, right? And species, I think we have how many? Two, three, three, right? And the island, I think, yeah, three probably, right? Okay, so let's see now what are the things that we can do with this data set, right? So let me quickly go again back to this one. Right. So imputation. Now, when we have missing data, what we can do? For example, uh, we use the pandas library and we load the data set, and data.head, what it simply does is it prints like the first five uh, rows of the data set, right? First five rows of the data set. Now we got the data set, and we got the data head, the first five. So you can see not available. So NaN is like not available, right? Not available. It's not available, or it's not entered due to some reason, right? I think the build length and build depth are these things, right? So the coming, so the Kalman depth and the Kalman length, right? Anyway, said something addition, right? So pandas. Now we are going to discuss about the data pre-processing. I mean, data feature engineering most with the pandas library, right? So the pandas has lots of features, lots of facilities we can use for feature engineering, for data pre-processing, right? So what we can do now, we can check whether is there any kind of missing values in the data set, right? So what we can do now, we have loaded it into a pandas data frame. So when you read it like read CSV, this reads and save the data set in a pandas data frame object. Data frame object, right? Pandas data frame object. Now, can you remember how to convert it to an umpire? You can put dot values here, right? But if you don't put dot values here, what happens? It simply get it to a pandas data frame. But if you use dot values, it get it to an umpire, right? Now we keep it as a pandas data frame, right? We keep it as a pandas data frame, and what we'll do, we can check whether if there is any missing values is available, missing values are available, right? For example, how you can do it, simply you can run this and then you can check whether the data is null, and dot sum simply gives you a explained kind of explained information about the null not available values, right? So you can check, okay, so it says this feature, no, any missing values, this feature, no, but this one, yes, two missing values are there, this missing values are there, right? This one, two missing values are there, this one, two missing values, gender, we have like 10 missing values, right? So it gives a brief it gives brief information about the missing values, how many missing values are there. Understood? Now, for example, in order to get this cleared, right? So I will manually, okay, let me uh, delete something from here. So that's a missing value, right? Nothing here, a missing value, right? A missing value. Now this is also a missing value, no value, right? Yeah. What I deleted, I have to keep it track. So 17.1, right? 17.1, I deleted it from here. Okay, 17.1, right? So I'm going to save it here, right? So now let us run this one and see whether this will be increased with one, right? So now it has like two, right? Two missing values. So I manually deleted a value and make it empty. So let me read it again and let me run this. Yeah, so you can see another missing value is recorded here, right? So that means it perfectly takes them, I mean, it can perfectly count the missing values, right? Understood? So let me assign that value again. Anyway, we'll keep it. We'll keep it. Don't worry about that, right? So we'll keep it. Okay, now, yeah. So what you can do, how to impute missing values, like, I mean, how to get rid of those missing values. So the most simplest way, right? You can read the data set. You can drop the not available values. Drop NA. Yes, we have a question. Yeah, exactly. Now there's a question. If is the not, I mean, empty and the NA are the same? Yes, exactly the same. Now I think someone added these NAs, right? Someone added these NAs, but not exactly needed to add this NA. You can keep, I mean, if there is no any value, like if you have empty cell, that also read as a empty value. NA is like considered as also a empty value, right? I think this NA is someone added manually or some due to some software or some due to some conversion method. The NA is there. මේ NA කවුරු හරි add කළා නැත්නම් ඔක්කොයි software එකකින් automatically NA කියලා දාලා තියෙනවා. But you can have like empty values like this as well. මෙහෙම නිකන් empty මුකුත් නැතිව තියන්න පුළුවන්. But this one and this one both treated in the same way, right? Okay, so coming back, right? So now, yeah, so drop NA. So this is the simplest method. What you can do now, can you see that the third one is like not available value is there, right? So empty values are there in the third one. So what it simply does, this drop NA, right? If there is any missing value, it's going to drop it. Just remove that row, right? It's going to just remove that row. It's not going to worry about the other values. That values, the whole row will be deleted from the data set. Understood? So that's what you can do using the drop NA, right? But not recommended always. If your data set is like a very large data set, like say, let's say you have 100,000 values, if you have one empty value, yeah, you can do that, remove it, right? But if you have like 100 data in your data set, 100 rows. So deleting one is like cost you, right? Understood. But not always recommended, but depending on your application, you can select whether you are, I'm going to just get rid of those things, right? The other way, simply fill NA with 0, right? So what you can do now, you can see this one, I mean the third element. So you can see, okay, 43 and 36, 7 point is there. In between, you have a missing value row, right? A missing value row. So in this one, drop NA, you can see it's simply removed, right? It's simply removed. So the other method is like, okay, don't delete it, but fill it with 0. Fill not A with 0, right? So that's the second method. So in this method, you are not going to remove the value, right? You are not going to remove the value. Instead of that, what you are going to do is simply fill it, right? Simply fill it with 0, right? But this is also not recommended all of the times, right? Why? Now, assigning 0 makes a big difference to your data set, right? What? If you apply k nearest neighbor, what happens? When you are going to measure the distance? Okay, for example, let's assume you are going to measure the distance between these two features, right? So it will be a very large value, right? So this will act as an outlier. So this is not, I mean, though it's there, not recommended to use always. I mean, this is very dangerous. Drop NA is quite good, but fill NA with zeros, right? I mean, not always 0, you can pick any number, right? You can pick any number, not always 0, you can pick any number. But this is not recommended always, but for, I mean, some applications you can do that. But simply what it does, it makes all the things right, 0 or whatever the value you are going to add here, right? So you can do it like this as well, right? So all the values will be filled with 10. So this is not recommended in the sense like, why? So if you use k means k nearest neighbor, right? So like, let's say, okay, you are going to get the distance between these and another data point. So this, like, you can see this value will be squared, right? So a very large distance will be calculated. So it is kind of like acts like outlier, right? So therefore, not recommended to use that, right? So the mostly used and the recommended method is this one, right? So what you can do with is without like, okay, here you have some where sorry, here you have some not available values, right? So what you can do is simply you can right, so data we are asking to like okay, from data this column, right? Data is this one. So from that, this column, we are asking to like fill the not available values, right, with the mean of that column. That's bit, I mean, that makes sense, right? That's fair to do that, right? So what we are going to do, this row, sorry, this column length, right? We are going like from this I mean, this column, the not available values, we are going to fill that not available values with the mean value of that column, right? Understood? Got it? So what happens now, in this case, nothing will be removed, right? Nothing will be removed. And instead of that, the missing value, the mean of that column will be assigned. තේරෙනවද? ඒ කියන්නේ දැන් missing value එකක් තියනවා මොකක් හරි column එකක. ඒ missing value එක තියෙන column එකේ missing value එක තියෙන column එකේ mean value එක එහෙම නැත්නම් average value එක අරගෙන ඒකට assign කරනවා. right? දැන් සමහර වෙලාවට අර අපි අයින් කරපු එකක් තියෙයි මෙතන. කීවෙනි එකද අපි අයින් කළේ? right. අපි අයින් කළේ 12 වෙනි එක. right. 12 වෙනි එක අයින් කළා තියෙනවා. බලමු 12 වෙනි එකට මොකද වෙන්නේ කියලා. um yeah. um 5 sorry 13. Let me get this clarified. So this should be like 1 less. Okay, so 4 and sorry, Kalman depth 11 and 4, right? 11 and 4. 11 and again, right? Okay, 4. Sorry, yeah, 4 and 11. Kalman depth 4 and 11. 4 and 11. Yeah, so this simply right, I'm not sure whether right. Anyway, now what it simply does is it doesn't remove it, right, the missing values. What instead of that, what it does is it fills the not available value with the mean of this column, right, mean of this column, and it replace it with the mean value. Missing values ඔක්කොටම ඒ column එකේ average value එක, column එකේ ඔක්කොම values වල average value එක assign කරනවා, mean value එක, right. But not only mean, for this one there are some others like we can use some other methods, mean value, I mean the average, mean, or the most frequent value, right, the median value, right, median value, mean value, and likewise we can use anything, right, not only the mean, you can use the median as well, most frequent value likewise. But you can see that if you have something missing in the gender, right, so that cannot be replaced with the mean, right. So what we will do, we for that kind of categorical things, the මේක වාට තියෙනනේ categorical එක බෑ මෙහෙම කරන්න. දැන් මෙතන මේ missing ඒවා තියෙනවානේ. Here you can see in the gender, the sex category also you have some missing values, right, not available values. So that cannot be it not make sense to replace it with the mean, right. It makes no sense to replace it with the mean. So what it does is it gets the count, right, count and gets the maximum. Now if you are not familiar what this count simply gives you, I will simply gives you what this count gives you, right. So you can see it counts the number of male, the occurrence of male and the female. Like it say, okay, the whole data sets 178 are male, 165 is female. So from that we take the index 0. What mean by index 0? Right? So the index of the 0 element, right? That means male. So the maximum it's going to count how many male and how many female, and the maximum value, the target which has the maximum occurrence, right. වැඩියෙන්ම තියෙන target එක දාගන්නවා මෙතනට. right? So value.counts gives you the counts for the male and the female or whatever the category is available. And zero, index zero is like the zero element, the index of that one. That means the male, right? Okay, so we are going to assign the most frequent target, right? The most frequent target. වැඩියෙන්ම තියෙන target එක දාගන්නවා. For categorical ඒවට. categorical ඒවට දාගන්නේ වැඩියෙන්ම ඔක වෙලා තියෙන එක. right? දැන් මෙතන male 178යි female 165යි. ඉතින් male එක තමයි දාගන්නේ missing ඒවට. right? Make sense නේ? වැඩියෙන්ම කියන්නේ. But it's not perfect. I'm not saying it's perfect. Sometimes it can be female, but what to do? We have the maximum of male, so we are going like with the probability we are going to think, okay, the missing values are also male. නේද? සමහරට missing female වෙන්න පුළුවන්. ඉතින් අපිට කරන්න දෙයක් නැහැ. අපි මොකද කරන්නේ? ඉතින් වැඩියෙන්ම තියෙන්නේ male නේ. ඉතින් අපි හිතනවා මේකත් male එකක් කියලා. Right? Likewise. Our feeling can be inaccurate. It can be a female, but nothing to do. We don't have a track on the missing data. So what do? We take the count for male and female. We consider the maximum count and assign the label of that maximum count, right? So that's what you do for classification things when you are going to fill the missing values. Understood? So that this is the most commonly used method, like mean and this kind of the maximum count, right? But you can use the median, right? You can use the most frequent value like this and the median, the other choices. Okay. Right. Another method when it comes to feature engineering, we have to always worry about not sometimes, missing value is one important thing, but sometimes there can be some like error values, not missing but error, right? You know that the last column can only contain 2, right? This row can only contain 2, either male or female, right? Either male or female. So if you are like having a kind of a doubt or right? Yes, if you have kind of a doubt and if you like feel like, okay, there might be like some error values here. So in this column, let's say that we have something than male and female, right? Something than male and female. So that's the error value, right? It always should be either zero or male. Male or female, right? Male or female. So what happens? Yeah, when it comes to like penguins, that should be like male or female, right? So then what we are going to do, right? So what we do is we are going to check whether the column, this column, right, is not female or male, right? We are going to check whether in this data whether there is a element which is not either male or female, and then we are going to get the location. So in that case, if you run this, there is some value, like 336. So let's see 336. Yeah, so what you have here, right? So what you have here is a dot, right? You have a dot here. See, it's a it's a not available value, but it's a error value, right? A false value. It should be either male or female. It's okay if it's a not available value, you can fill it, but this kind of things, what happens, right? So there can be issues, right, with these kind of values, accidentally entered values. So you can check whether in our data set you are having those kind of values, right? Now you see we have to worry about lots of things when it comes to data sets, right? So you can't always add data sets directly into machine learning algorithms. So that's why this topic is important, and that's why we are discussing about this topic, right? So you have to check about these values, so you can check whether those kind of values are available, right? So if those kind of values are available, now it says, okay, 336, you have a dot here, you have a dot here, right? So in that case, I'm checking whether that kind of not available, I mean, kind of incorrect entry is there in this column. If that, if such a, in such a situation, it gives us the uh, number. So what we can do is we can drop it, right? So we drop it. That means we just remove it from our data set, right? We just remove it from our data set. We can't keep it. Or else you can replace it with male or female also, that also can be done. But or else you can just remove it, right? Or else you can, as I mentioned, you can replace it with male or female, right? Okay, so that's about data pre-processing. So please do these things before applying your data sets into machine learning algorithms, right? Machine learning algorithms. Okay, so thereafter, a very important topic, what to do when you have categorical features, right? Categorical features. So what I mean by categorical features, like this, right? So here, Adley, Torgenson, right? Gento, Bisco, right? Likewise, Gento, right? So I don't know, like these are species and islands and these kind of things, but these are categories, right? So it's not a numerical value, right? So let's say like you have a vehicle data set, the color of the vehicle, yellow, white, gray, black. That's a category, not a number, right? Understood? Likewise. So when you have, like, you know what a categorical feature is, right? A category, not a number. So we can't deal with categorical features, right? So can we apply a color of a vehicle into the k nearest neighbor algorithm? Can we measure the distance between two colors, right? Right? Or can we, like, let's say, we have the hometown, or the yeah, hometown in a data set, right? So let's say Kurunagala, Colombo, right? K-Goal, right? Goal, Hammantro, likewise. So can we measure the distance between Kurunagala, I mean, in K nearest neighbor, distance between Kurunagala and Colombo? Yes, there is a distance in kilometers, but that makes no sense, right? Understood? So likewise, if you have categorical features like color, the hometown, right? Likewise, which has no number, which is not a number, not a numerical feature. If you have a categorical feature, definitely you have to convert it to a number before applying it to your data set. Definitely you have to do that. That's something must you have to do, right? Definitely, if when you have categorical features like this, towns, like islands, names, right? You have to convert it to a numerical form before applying it to the data set, right? Understood? Now let's say, yeah, uh, yeah. So what we can do, categorical encoding, right? So what I'm going to do before doing this, like we have some numerical features, right? We have numerical features, so we filtered them and we filled them with the mean value, and we did lots of things for those things, right? So we keep them away, the numerical features. We are not going to worry about the numerical features. We will come to back them later. But now what I'm going to do is talk about the categorical encoding. So I'm going to take the categorical things available in this data set, right? This one, and this one. So you can see these are the species, and the this one, the sex, the gender, and the island. So those are the categorical features available in this data set. So what we can do, I'm going to take those things and I'm going to convert them into categories, right? I'm going to convert them into categories. So what it simply does, right? So this is called the simply we encode the data set into categories. So what simply this does, now I'm going to convert this into categorical form, right? I'm going to convert this into categorical form. So this is how we are going to do it as type category, and we are going to make it to equal to this, right? So thereafter, I'm creating another uh, like a separate data set by dropping um, yeah, actually this is not required. I don't know. Sorry. What we do here is that we have to before doing any categorical conversion or before encoding it to a categorical form, the first thing that you have to do is you have to mention or you have to indicate that these are categorical features, right? So we have 3 categorical features in our data set. So what we need to do is we have to mention that these are categorical features. So you can do it like this. So data, we are going to take a row, this row, and we are going to convert it as type category. So now onwards, this point onwards, that the algorithms or the pandas or whatever the tools that we are going to use, that they know that, okay, this is a categorical uh, feature or categorical categorical feature. So first you have to mention, you have to convert it to a categorical format. I mean, you have to convert the type of that feature into categorical. So this is how we are going to do it, right? So you have to mention that it's a category. Now after doing this, okay, so if you let's say, yeah, I mean, I will run this. And so before doing this, if you just check the data types, right? So it just say it's an object, right? Object. So now it has identified these as numerical things. So it says it's the data type is float, but these like unassigned, they remain like objects, right? So by doing this, what happens? We each column, we convert them in the type. We convert the type into category. So thereafter, when we print the data type, right, the data type of the data set, right, when we print the data type of the data set, so it simply says us, okay, now these are categorical. Now we change the type of this data set, I mean these columns, into categorical form, right? So thereafter, what we are going to do, I'm going to take the categorical data separately, and I'm going to drop other numerical data like the Kalman length, the Kalman depth, flipper length, body mass. Those numerical features, those will be dropped, and I'm going to take only the categorical data into a new data set called categorical data, right? So it will be taken into a new data set called uh, categorical data, right? Categorical data. So that's what we are going to do. So from the original data set, we drop these numerical features and get uh, the get only the categorical features, and we get it something called categorical data, it into something called categorical data, right? So thereafter, now we are going to talk about how we can convert these labels. I mean, how we can give a label to these categorical features, right? The first method, now keep that in mind, you have to first change the type of these columns into categorical, right? So this is how we are going to do it. After doing that, what you can do it, you can take the categorical data separately, the categorical feature set separately by dropping the other features, and you are going to get the categorical data only. Then using this method, the first method, you have several methods of using the encoding, right? The categorical label encoding. The first one is just the simplest label encoding. So this is how we are going to convert a categorical feature into number. The first method, converting a categorical feature into number, is label encoding, right? So this simply gives a number to the label. I mean, numbers to the features, right? So what it means. So what I'm going to do now, Yeah. Let me print the categorical data. You can see now, okay, this one is 0, right? Um, yeah, let me run it again. Why it's coming like 2 here? It should be 0 and 1. Um, uh, 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 uh. Probably, I think, yeah. I think we can drop the not available. Yeah, right. So now it will be okay. This one also we have removed. That's the case. Now I think that's fine. That we have like a dot is there. Can you remember? So it's going to consider the dot as another category, male as another category, female as another category. So I have run this again, right? Um, um, give me a second. Why it's not coming like 0 and 1? Um, okay, let me run this one time again. Okay, from the beginning. Fine. Okay, I run everything from the beginning. So it now okay, right? So what simply it does, right? What it simply does now, it's going to give a number, right? So each of the thing, right? So like male is 0, right? Female, sorry, male is 1, female is 0, right? So this Adili is 0, right? Then Gento is 2, like whatever the in between thing is 1, right? And this one Togerson is 2, right? And Bisco is 0, right? Likewise. So it's like this simply, right? Setosa 0, versicolor 1, virginica 2, right? Likewise, using this method, for each column, you can give a number to each category. I mean, each categorical label, right? So that's what you call label encoding. Simply, you can do that, right? Then the second method is one-hot encoding. So this is uh, bit different when it compared with the earlier method, right? Bit different. So what it simply does is that uh, it gives a right. It gives a category for each label, right? I mean the each category in the feature, right? It gives a new category for each uh, feature in the, I mean each category in the feature, right? So it's like this now. If you right, so you can see now we have this one. Let's say okay, we will start with this. Okay, gender. We have two things, male and female, right? So male and female now are being considered as two categories, male category and the female category, right? So if that data set is like the gender is male, so this will become 0 and this becomes 0. This becomes 1 and this becomes 0, right? So I mean this one, like let's say the island has I think give me a second. Yeah. So what I was talking about, like one hot encoding is doing something like this. Okay, this one simply has I think how many right? So these are the categories of the island. So these are the categories of the island, right? මෙන්න මේ island එකේ මේ තුන තමයි ඉන්නේ, right? So island has these three. So what happens, right? So island, there was one feature, but now we have two features, I mean three features, right? So for each different category, there will be a new feature created. Understand? For each new category available, there will be a new feature created, right? But the thing is, okay, if it is Togerson, right? If it is Togerson is 1, Dream and Bisco are 0. Understood, right? So that's called one hot encoding. Now this also can be used, right? Now the earlier one, what it simply does, okay, it gives a number, right? It gives a number like, okay, Togerson is 2, right? And if you have like Bisco, it's 0, and Dream will be 1, right? So those are island names, right? And this also the same. So the male, I mean the gender, male and female, male 1, female is represented by 0. But here what's the difference? One hot encoding, for each different feature, I mean each different category available in each feature, there will be a new feature created for each and every category, right? So island කියන එකේ තියෙනවා categories තුනක්, Togerson, Dream and Bisco. ඉතින් ඒ තුනට වෙනම categories තුනක් හැදෙනවා. But now the first row is actually a Torgerson. So what happens? Torgerson will be 1 and other 2 become 0. Right? So this is also another method you can use for categorical features. So you can convert it to one hot encoding. Right? Okay. So we have a question. Let's see. Yes, exactly. This is binary representation for each different category. Yes, exactly. Binary representation for each different category. Right? So one hot encoding, then this can also be used in categorical conversion, right? And then the most weird encoding method called target encoding, right? Target encoding. So what this target encoding simply does, bit hard to understand, right? But I will explain now. This target encoding should be always should be done with respect to another feature, right? Target encoding will be done with respect to another feature, right? So it's like this now. Okay, so we are going to take this yeah, we are going to take the yeah, okay, so it's like this now. Categorical data grouped by island and let me um, yeah, so here now I'm going to take the categorical data grouped by island and species, right? Right. So then what happens? We are going to calculate something called island means, right? So we are going to first convert this species into a categorical form, right? We are going to convert this into a categorical form, right? So let me show you this one, what this means. You can't view it. Yeah, but anyway, yeah. I think here you can view it, right? Okay, anyway, let me explain it from the Excel file. I think it would be easy, right? Okay, so we are going to get a mean value. It's done like this, right? So you know that, right? So if we give a category for this one using labeling, right? Label encoding, you know that, yeah. So if we use label encoding, what happens? We can give a number to this. Like let's say we can use 0 here. Right? So we can assign 0, right? So if you use just a label encoding or parameter man kata karapeka use karot, right? So all of these become 0, right? Right? So then this would become 1. The chin strap. So these will be 1, right? So then the gento will be 2. So I'm talking about like giving a label using the label encoding. Okay, right? Okay, so we gave a label encoding for the to the species, right? And then what we are going to do now, if we want like how the target encoding is done, right? How the target encoding is done. Okay, this one, what I'm going to do, I'm going to take the, now this is a bit awkward and this is a bit weird, but I'm going to take the average of the labels of this one, right? So it's like this. Okay, I want to get the label for this label, I mean the Torgerson, right? I want to get the label for the Torgerson, right? So what happens is I'm going to count, or I'm going to get all the Torgersons available here, right? All the Torgersons available. Okay, these, there are Torgersons, there are some Torgersons, right? And there are again some Torgersons, okay, and there are again, where, I think that's all. So those are the only Torgersons available, right? And what I'm going to do, right? What I'm going to do is simply add the value here, the corresponding value of this one, this one, and another set of Torgerson, right? I'm going to get the value of this one, this, I mean, the corresponding value of the corresponding values of the species for the label Torgerson, the category Torgerson, right? The corresponding species values for the category Torgerson, right? And I'm going to add those values of the species and get the average, right? Now, what will be the average then here? Yes? Yes, 0. So Torgerson becomes 0. The label of the Torgerson becomes 0, right? Okay, then how to get the Bisco, right? Bisco label, right? So Bisco label simply, okay, add these values, okay, 0, and add these values, 0, and add these values, those are also 0, and add these values, right? Got it? So these highlighted cells, these highlighted values of the species, right? You are going to get the average of those values. So what will be the average? You can't exactly say, right? So we can't exactly, so that's something, some kind of a value. I can't exactly say. So how to calculate the dream? Again, okay, take the corresponding values of the species for the category dream, right? Okay, this value, this set of values, and these values, right? So then calculate the average of those, sum them up, add them up together, and get the average. So that will be the label of the dream, right? So by doing that, this is what you are going to get. මේක තමයි ඔය එන value එක. Now, it's quite weird, right? I mean, why we are doing something like that? Actually, no use to do that, right? What's the purpose of doing such a thing? Actually, this is a very advanced encoding method that we can use, but not for all. There are several specific applications that we can use this for, right? In machine learning algorithms, sometimes this gives great results, right? Understood. But anyway, this always has to be taken with another, with respect to another feature. That's one important thing. That can be any feature, not always species. You can use any other feature as well, but always it should be taken with some some other with respect to some other feature, right? With respect to some other feature, right? Understood? So now similarly, how we are going to get right here, now you can see the values that you are going to get for the gender. So it's like categorical data group by gender with respect to species, right? And these are the values that we are going to get. So now this will be the label, right? So this will be the label, right? This will be the label for female, and this second the label will be 0.92 likewise, right? So now the label of visco is 1.43. This is the label of dream. This is the label of Torgerson, right? Understood? Got it? So we'll discuss more about these things. Like, I mean, we have to use these things and everything, but I just explain a different methods of encoding of categorical features, right? Categorical features, encoding of categorical features. So the label encoding is the most straightforward method. So giving a number to the label, like setosa 0, versicolor 1, virginica 2, likewise, right? The other method is one hot encoding, where you are going to create different feature for each category available in the features, right? Then give a number like this. So Torgerson 1 and other islands are 0, 0, likewise. So then the target encoding bit awkward method, right? Okay, so the next thing comes under uh, the next important thing that comes under the feature engineering is handling outliers, how to deal with outliers, right? So what do you mean by outliers? Can you remember? Huh? We discussed about this in the first day as well, right? We have discussed about this in the first day as well, right? So outlier simply a data point which deviates, right? Which has a like a kind of a very clear deviation from the whole distribution, right? The whole distribution. Got it? So now, for example, like unfortunately, let's say, so you are working with the height and the width case, right? Height and the width case. So let me show you the height and width thing that we explained last time. I think last time did we do it? No, the rain thing, right? The height and yeah, right? So let me add a value. I have like weight 150 and sorry. Right. So I will show you that thing. What I did was I wanted to explain this in a, okay. Right. See the outlier, right? So can you see the outlier effect, right? So now, I mean, is this possible? This kind of a data point? Is it a possible thing? So this is human height and weight, let's say weight and height. So is it a possible thing? Yes, what do you think? Is it a possible thing to happen? Yes or no? Okay, others, what do you think? Is it a possible thing to be happen or not? So these are weights and heights. So the weight is like 150 kilograms and the height is somewhere around like 100 centimeters. Is it possible? Sometimes yes. Others, what do you think? Is it possible? I mean, if you take the real example, real world, is it possible? Yes, this is quite possible, right? I mean, yeah, there can be people, right? So sumo, right? The Chinese sumo, have you seen, right? Right? So these guys, see, right? So very, I mean, short and right. So the weight can be right. So few kilograms, right? I mean, 200 kilograms. So this can be there, but the thing is, this said to be outlier. Why? I mean, it's not usual. It's deviates from the usual behavior, right? But these kind of points can be there, but very rare. That's the most important thing. Very rare, but possible, right? So in such a situation, what you have to do, like you have to get rid of those things, since those points can make a huge difference for your things, right? Right. So in this situation, what you have to do is you can have this kind of a box plot, right? Box plot. So this is a very important thing. This box plot actually now this is used in trading as well, right? So this box plot, what this gives is like this point marks the maximum value of that column or that feature, and this marks the minimum value of that feature, right? And there are some there's a box, right? So there will be 2 points like this, okay, q1 and q2, right? And this is the median. Actually, this is the median, right? Yeah, the median, and q1 and q2. So this actually marks the box, right? So now this gives you a clear understanding, right? So if you have something like this, it says, I mean, I will explain about q1 and q3, but you know what q and q3, right? So it's 1.5, yeah, the IQR, right? The median, the lower end of the data, right, q1, and the median of the higher end of the data, q3, right? So q3 and q1. So this actually, okay, if you have a data set like this says outlier. Why? So it's, I mean, it's quite deviated from the median, I mean, this box, right? And this also outlier, right? A very low value, right? And also there can be like this kind of values as, right? So this is again marks a outlier effect, right? So you can, what you can do is simply you can always plot these boxes and see whether it's like suffering from outliers, right? So here some indication of outlier, right? Some indication of outlier. Here also some indication. Like if there are no outliers, they should be like this, like balance between these two, and like this is not going far away from this box, right? It should be very close. I mean, both the lower and the upper ranges should be very close to this box, right? So here also, like you can get the understanding, right, about the outlier, whether there is an outlier effect, right? So anyway, if there is an outlier, what you can do is simply you can simply apply some equation from the standard deviation. So let me show you, right? You can neglect this effect using the standard deviation. That means this two equations, right? So what do you mean by standard deviation? Simply, I think most of you know. So this is how you are going to calculate the standard deviation. So x will be the data points and mu will be uh, the mean, and n is the number of data points available in the data set. And this is how we are going to calculate this, I mean the standard deviation, right? So usually in a normal distribution, normal like a general distribution, the standard deviation, this is the median or the, I mean the mean, right? The mean. So the standard deviation, like if you if you what it simply says, right? The empirical rule, what it simply says, around 68 point of the whole data points are lied, right? Are lied within 2 standard deviations from the mean. That means, okay, so you are going to calculate something called standard deviation. So that can be calculated from this equation where it use the sum of like x means the data point values of the data set, and mu is the mean, and you are going to square it up, and when you are going to divide it by the number of data points, you can calculate the standard deviation. So the theory simply it says, so from the mean, if you like in the x-axis, if you uh, consider range like mean minus 1 standard deviation and mean minus plus 1 standard deviation, so that range, so it says 68 point from your data lies in this region, I mean this region, right? That's what it says. So like if you take like 4 standard deviations, like a range of 4 standard deviations plus 2 standard deviation minus 2 standard deviation, so in this range 95 of the data lies, right? And if you take like 6 standard deviations, that means 3 minus 3 and plus 3, so there are like 99.7 99% 0.7 data lies with 6 standard deviations, right? So what we do here in this one, we cut off the data. Now the factor is like you can change it to 2, 4, 6, right? 2, 4, 6, right? So what we do is the upper limit, we cut all the data, right? We cut all the data, right? So we define these boundaries like the lower and the upper limit. Like so if you use 2, you can use 2, 3, I mean 2, 4, 6, right? So anyway, if you use 2, let's say, so you cut all the data, these data you are going to cut off. So you are going to consider these as outliers, and these data will be cut off, right? You are going to only keep these, right? So what you can do is you can get the lower and the upper limit. So lower limit, upper limit will be this one. If you use 2, factor 2, this will be the upper limit. If you use the factor 2, this will be the lower limit. And what you are going to do, this is how we are going to cut them off, right? This is how we are going to cut them off simply, right? So you are going to cut them off like the values less than the upper limit, sorry, values greater than the upper limit and values less than the, sorry, what you are going to consider is the values less than the upper limit and values greater than the lower limit, and others will be removed, right? So now the original data set what you have is like 243. So if you like remove data based on this method, if you now get the new data set, right? The new data set, there will be 337, right? So like 5 of the data points are removed approximately to, how much was it? 247, right? Sorry. 243, yes. Okay, my question, can you answer this? So if I use the factor 4, is the data set, is the values that I'm going to get, like the whole number of values, is it going to increase or decrease if you use a factor of 4? The number of values that I'm going to get, not removed, I'm going to get, will it be increased or decreased? Okay. Yes, exactly. It increases. Since why? Huh? Since you are now taking like 4 in the sense, now earlier you took these data, only these data, right? Now you are going to take like 4. That means you are going to take like more data, right? So very straightforward thing, right? So scaling can be done for, sorry, not scaling, this standard deviation kind of what you call flipping, or not flipping, standard deviation saturation can be used to get rid of outliers, right? Whatever the outlier, I mean, whatever data points, I mean, like they are uh, after these points and less than these points will be removed, right? So very straightforward thing. So you can use this method to do that, right? Okay, so finally, the scaling, one of the most important thing when it comes to machine learning, and this is very important when it comes to deep learning and neural networks as well, right? So now you can see our data set. If you consider our data set, so the value ranges are different to each other. For example, right, the value ranges are quite different to each other. Right now, this length is in a different range, and like the body mass is in different range, like 3000, 4000 range, right? So this is in 18, 20, right? So likewise, but this is in 100 range, right? 100 and 200 range. So these values are in different ranges, right? These values are in different ranges. So sometimes, not all, but machine learning algorithm sometimes fails, and sometimes fail to give results when these values are in different ranges, right? Not exactly like most of the machine learning algorithms, but when it comes to deep learning, the neural networks fails when you have like different range values, right? So the scaling is simply used to convert the uh, convert the data set given into a, like, scale it down to a common range, right? Scaling it down to a common range, right? So like I'm going to take the body mass, only the body mass, right here. I'm going to take the body mass from the data set, and I'm going to calculate the mean and the standard deviation of the data, that the body mass column, the body mass feature. I'm going to calculate the standard deviation and the mean, right? So when you are going to calculate that, you are going to get these values, and you have this kind of a this is a kind of a histogram which shows you the distribution of uh, the weights, right? So what we can do now, right? What we can do, yeah. So what we can do is we for scaling we have different methods, right? The first scaling method is standard scaling, right? So what it simply does, from each value, the mean will be divided and mean will be subtracted, and it's divided by the standard deviation, right? So simply what it does is it from all the, now for example here we have the body mass. So from all the body mass values, we subtract the mean and the right, subtract the mean and divide by the standard deviation. So then what we are going to do, what we are going to get is something like this. Now you can do it like this using this equation, right? The from a scalar and dot preprocessing is standard scalar and standard scalar object and standard scalar fit transform. You are going to provide the data, and it will apply this equation for you, and you are going to get the new data, right? So if you calculate the new data, the mean, it will be something like this. Now this is after applying this equation. So if you calculate the mean, this is the mean, and this is the standard deviation. So we are going to scale the data set down, right? So that's one method of scaling called the standard scaling. And then the min max scaling. So this is most straightforward method for min-max scaling. Now, I will explain how this is done using a very simple example, right? So when you have like an image, you know that the image range is 0 to 255, right? Right. So if you want to convert between 0 and 1, you know what to do, right? So let's say this is IMG. How are we going to do that? Huh? You are going to divide the image by what? Huh? Any idea? If this image, like all the pixels are between 0 to 55, if you want to convert this image in between 0 and 1, all the pixels, what you can do? This image should be what you have to do. Yes. If you divide by 255, what happens? Huh? If you divide by 255, what happens? Yes. If you divide it by 255, this will convert it to 0 and 1 simply, right? So this is the min-max scaling simply. So the equation is something like this. Okay, so let's say that we have, the x should be minus by the minimum value of that data set, right? X min and x max minus x min. So this is the equation that we are going to use to convert any kind of a data set with any range between 0 and 1, right? For example, let me show you this, right? I will show you applying this, right? Okay, so let me get a simple array np dot random dot random random integer. So I'm going to take like 0, 100, not 0. Let's say like, okay, 40 and 120. And I'm going to take like, okay, I'm going to take like 20 values, let's say, right? So this is what we are going to get in this one. Right? So what you can do, you can simply convert this data set between 0 and 1 by doing like this. Array minus the minimum value 40, right? And it should be divided by the maximum value minus this value. Right? So all the values will be 120, right? So this is 120, right? So all the values now you can see are converted between 0 and 1, right? 0 and 1. So what we have to do is the x value minus the minimum value divided by the maximum minus minimum, right? So that's how we are going to do it, right? Okay. Yeah. Right. So that's how we are going to use min-max scaling. So what's the important thing in min-max scaling? What you are going to get is no matter what's the data set that you have, right? No matter what the data set you have, that data set will be simply converted between 0 and 1. All the values will be converted between 0 and 1, right? All the values will be converted between 0 and 1 when you are going to use min-max scaling, right? So that if you want to like simply use, right, here the most popular scaling technique is normalization. It scale all the data in the 0, 1 range, right? No matter, right? So when you deal with neural networks, this is the most frequently used method to scale down the data set, right? Yeah. So this one is quantile transformation with bit complex, right? But using the library, you can directly do it, right? So what simply it does, now if you have the distribution like this, right? If you have the distribution like this, sometimes the machine learning algorithms, right? Sometimes machine learning algorithms require the distribution of the data in uniform or normal form. So what do you mean by uniform or normal? This shape, right? So this is something, some, not all, but some machine learning algorithms requires the data set in this form, right? The uniform form. So this is what you call the uniform form, right? Or the normal form, normal distribution. So if you like, if the machine learning algorithms which use this form, what we can do is simply, we can use this quantile transformation, right? And it's simply whatever the data set you given, it can convert the data set, right? It can convert the data set into this kind of distribution, right? It can convert the data set into this kind of distribution, right? So some of the machine learning algorithms needs this distribution before applying the data set into a machine learning algorithm, right? So that's required. Therefore, what we are going to do is, before applying it to the data set, we use this quantile transformation and convert the data set into the standard from the normal distribution form, right? So that can be done simply using this quantile transformer. What you have to do is, whatever the data set you want to transform into this form, you should apply it here. You are going to create an object called qtrans, and qtrans use the fit transform method. We apply the data set we want to get converted into this uniform form. Then you are going to get it back, right? So then you can get this kind of a uniform distribution, right? So that's another method of doing it. Now the thing is, you have to read a bit and you have to find these things bit. When to apply, okay, quantile transformer, when to apply min-max scaling, when to apply standard scaling, right? So now you have a basic understanding about data sets, and you have a basic understanding about, okay, how to like what these pre-processing algorithm simply does, right? So what you can do is, you can use them and simply do these things. So you have read a bit and you have like search. Now, as I mentioned, this is something that this is kind of a start, as I mentioned, right? So this is the beginning for most of you, right? So you have to now, based on these theories and everything that we discuss, you have to find a method of doing these things, right? We have to apply these things. You have to find where to apply these things, right? Okay, so yeah, so that's pretty much everything. And we have to discuss about image extraction, right? Image feature extraction, right? Now that means this is simply explains how to, what to do when you have images, right? What to do when you have images in your data set, right? If you have images, what are the pre-processing techniques that you can use for images, right? So this is what simply it covers. But thing is, since the time is not enough, I will upload this as a tutorial, right? How the image feature extraction is done. Simply when images are there, what are the pre-processing techniques that you can do before applying the image as it is to a data set, as it is to a machine learning algorithm, right? So this is what, when it comes to images, right? We can't apply images as it is to machine learning algorithms most of the time. So we have to do something, we have to do some pre-processing. So when it comes to images, what we can use, what are the pre-processing techniques we can use for image feature extraction? So that will be discussed under this topic, and I will upload that tutorial into your, the section as a tutorial. And after this, we have a nice little implementation like this. right? This kind of lane detection, not perfect, but within few lines you can detect lanes and do something, right? So this will be explained under that topic, like the feature extraction in images, right? Okay, so yeah, now you know what are the things that you have to do before applying data sets into machine learning algorithms, like the outliers, right? Scaling and categorical features, encoding of categorical features, right? So you have to always, before applying the data set, you have to do that, right? And then only you are going to apply it to a machine learning algorithm, right? So keep that thing on your mind, right? So that's the most important thing. So please go through these things again and try to implement the codes and see, apply it to your data sets and see how you can do this, right? So I will explain about the feature extraction of images in this the coming tutorial for today, right? Okay, so from here now, I think the theory part will be, I can conclude the theory part, right? So this will be provided as a tutorial, as I mentioned. So I think, yeah, so that's pretty much everything. And I think that you got uh, good knowledge from this workshop, right? But thing is now, this is the first, this is the first machine learning 5 days workshop that I have organized. Earlier, what we had was like 3 months workshops in weekends from like 9 to 5, 9 a.m. to 5 p.m. So 8 days per week, 8 days per week, 8 weeks, 8 hours, right? 8 hours per day and 1 day per week, right? අටේ නමේ ඉඳන් පහ වෙනකං තමයි අපේ courses තිබ්බේ කලින්. So they were like 3 months courses, right? But with this situation, the pandemic situation, what we have done is like I have decided is since it's quite easy and you can stay at home and in the evening. So we have decided to have this kind of rapid and fast track workshops, 5 days workshops. Since these are online workshops and the content we can provide content and as videos. Therefore, I decided to simply conduct it consecutive 5 days, right? So anyway, now I'm open for your suggestions, recommendations, since you are the first batch. First batch for the 5 days workshops for machine learning, right? Since you are the first batch, so I'm expecting some feedback from you, right? So I'm always open for these feedbacks and recommendations. So I'm happy to hear your feedback, and I'm happy to make modifications to these courses and update the content or update the content, or reduce the content, or add something to the content, or uh, change the method of conduction. So I'm quite happy to do that, right? So I'm expecting some feedback from you. So what you can do is, like, I'm not going to I'm not going to take it personal, right? So I'm personally asking from you, right? So what you can do is you can drop me a message, right? Or you can drop me a message, or else I can upload the Google form, which does not collect email addresses, and I can get your feedback as well. But simply what you can do is you can provide me some feedback. Please drop me a message and say whatever the suggestions or whatever the things you feel. If you feel it has great content and everything was fine, I'm happy to hear that as well, right? Okay, so one last thing, one small request from you. So if you if you can provide some feedback, uh, you can do it in our website as well. Um, and also, right, So you can go to my Facebook page as well, right? So my Facebook page, and here simply you can uh, provide a review, right? Whatever thing, right? It can be a positive review or negative review, right? So if you can provide me a review, I will be grateful, right? Simply if you can go here and what you can do is I think somewhere, yeah, go to reviews, right? And you can write your review here, right? You can write your review in my Facebook page, and in addition, uh, you can do it for our right. You can do it in our edescope site as well. So please provide the review here, and also if you can simply go to these courses, right, and provide the review, that would be also grateful. I would be quite grateful for you if you can provide the review here. You can, if you can write a review in the course, right? So it's highly appreciated, right? So others can see, others can get to know about what we are doing, right? So that's highly appreciated. And the other thing is, yeah, so reviews on those things. And so if you have any recommendation, any suggestion, I'm open for that. So please drop me messages or just give me a call, right? Don't hesitate. So give me a call or drop me a message and tell me what are the modifications to be done, or what are you, any suggestion from your side, right? So you can let me know that thing, right? And other thing, like if you want any help, any assistance, right? So if you are working on your project, if you are working on your final year project, or if you are working on your project in your working place, anything is fine. You can call me or you can drop me messages, but the most effective way is calling me. I'm I'm always happy to answer calls rather than replying messages, right? So please call me, right? So it's not going to be a matter. Don't hesitate. Feel free to call me and get some doubts clarified if you have any, right? So I always help you now. Actually, I'm always like helping with these research, and doing lots of helps with coding sites and theoretical part as well. So if you have any doubt, if you are working on your uh, in your kind of research or projects, so you can get help from me, right? So stay tuned, and we are going to take the next intake for the deep learning, the 10 days workshop, and it will be like on January. The scheduled day now is 11th of January, so I will provide all the details on the WhatsApp groups as well, right? Okay, so thank you very much. And other than that, if there is any feedback, if there is anything you have to say from your side, you can tell them now. You can drop message from chat, or you can just unmute your mic and you can tell if there is anything from your side. Yes, so what do you think? Is it good, or what are the modifications, or what, any recommendations from your side, any suggestions? What do you think?
Hello, sir.
Yes, Mushfiq. Yeah.
Uh, I found this course really helpful. So I'm doing this subject for my semester, for this semester,
Okay.
and I was just given a very primitive knowledge on the subject.
Yes.
And after following this course, only I understood the in-depth uh, application that we can do using machine learning.
Yeah.
So finally, I would like to thank you very much, sir. That's all.
Yeah, Mushfiq. Yes, thank you very much. I remember that you dropped me a message before starting the workshop about the content. So I think you are satisfied now. So happy to hear that. Thank you very
Sure,
much.
sir. Yeah. Thank you.
Excuse me. That for me, it's a very excellent course. I learn a lot of things. As a suggestions, I like to have a breaking day. That's mean it's a continuous 5 day. It's a very that's we have to go tutorials and everything and following ups. lot of things to it's getting if it is possible to arrange a break-in day, that's after 2 days. If it is possible to arrange one break-in day, it's very effective the course, I think. However, it's a very good. Thank you very much for giving this type of knowledge.
Yeah.
Thank you very much.
Yeah, Samir, thank you very much. Yeah, I will look forward to that. So that's a good suggestion as well. So probably we can have something around like Wednesday and continue up to Saturday. Yes, it can be done. Yeah, let me have a look about the possibilities. Thank you very much. Yes, any others? Anything to be, anything to highlight?
I think sir, this is the content was excellent. The addition to machine learning that we can get additional knowledge of Python, GUI creations, and all the other stuff. So I think this is an excellent course to others also have to find those who are doing machine learning stuff.
Yeah. Thank you very much, Mamadou. You always contact me and asking doubts and everything. So thank you very much. And yeah, the thing is now, as I mentioned, please go through the materials. Now you have like 2 weeks break. I mean, if you are interested on participating the deep learning workshop, you have some time now. So please go through freely, right, with the material and try to get the knowledge, the most of out of it, right? And if you have any doubt regarding the things, and you can always contact me. Okay, so any other one willing to say something? Okay, seems that's all right. Okay, anyone? Okay then, so thank you very much, and we will meet again with advanced workshop like probably deep learning. And meanwhile, if you have any doubt, any concern, any suggestion or anything, if you want to contact me, please don't hesitate, drop me a message or give me a call. So I'm there for you to help and clarify those issues if you may have, right? So thank you very much, and we will meet on next time, and have a good I wish you all the best, and try to keep doing and try to stay with machine learning and do your stuff, and there will be always a demand for you in the future, right? So thank you very much, and we will meet again. Wish you all the best.
Thank you, sir.